Every map of India you have ever looked at is, well, in a very real way, lying to you.
It is definitely presenting this illusion of stability, right?
Exactly. I mean, you look at a map and you see the solid black lines of state borders, the little stars for capital cities, and, those squiggly blue lines marking the rivers.
Right, and you naturally assume permanence.
Yeah. You assume those blue lines are just fixed features of the earth, like a highway or a building or something. You think, okay, that's where the river is, and well, that's where it has always been.
But when you actually dive into the science of drainage, and I mean really dive in, you realize those static blue lines are just a snapshot of a highly violent, incredibly active process. We are looking at a geographical landscape that is alive.
It is the absolute definition of a living, breathing, constantly shifting system. I mean, those blue lines are basically massive, heavy, moving saws that are actively tearing the subcontinent apart,
Carrying mountains to the ocean.
literally rebuilding the land right beneath our feet. So, welcome to this custom-tailored deep dive. Today we are taking you, the listener, on a pretty wild journey through a textbook chapter simply titled Drainage.
It sounds so dry, but it's really not.
No, not at all. Specifically, we are exploring the geography, the life cycle, and the immense, frankly terrifying power of India's river systems and lakes.
And we have a very specific mission for you today. Because, let's be honest, tackling a dense geography text can feel like staring at a wall of academic jargon.
Oh, absolutely.
So our goal is to help you fully master this material, bringing you right down to the ground level without, feeling overwhelmed by all the terminology.
So here's the format. We are going to read the original source text to you verbatim, paragraph by paragraph, and sometimes even sentence by sentence. But we won't just leave you alone with the academic text.
Definitely not.
We're going to immediately break those concepts down into plain, beginner-friendly language. No skipping the hard parts, no vague summaries. We are unpacking every single concept.
By the end of this deep dive, you're going to look at those blue lines on a map and see them for what they truly are: raw forces of nature.
Exactly. Forces that literally shape human civilization. So let's just jump right in. Let's start right at the beginning. The text reads, quote, "The term drainage describes the river system of an area. Look at the physical map."
Let's pause there for a second. When geographers say drainage, it's easy to immediately picture the PVC pipes under your kitchen sink.
Right, that's where my mind goes.
But we need to scale that up massively. They are talking about the entire interconnected network of natural water flow across thousands of square miles.
Okay, that makes sense. The text continues, quote, "You will notice that small streams flowing from different directions come together to form the main river, which ultimately drains into a large water body such as a lake or a sea or an ocean. The area drained by a single river system is called a drainage basin."
Okay, the drainage basin is the foundational concept for everything we're going to talk about today. Think of a basin as a massive topographical bowl.
A bowl.
Yeah, a giant bowl. If you pour a cup of water anywhere on the inner slopes of a bowl, gravity is going to pull that water down to the lowest point in the center, right?
Obviously, yeah.
Well, in geography, a drainage basin is an area of land where all the precipitation, every single drop of rain, every melting snowflake collects and drains off into a common outlet, usually a single river that eventually reaches the sea.
So if I'm standing anywhere inside a specific river's basin and I spill, like, a bottle of water on the ground, that water is theoretically destined to end up in that specific river.
Precisely. Every single inch of land on Earth belongs to one drainage basin or another.
Wow.
Uh,
Okay, which brings us to the next sentence in the text. Quote, "A closer observation on a map will indicate that any elevated area, such as a mountain or an upland, separates two drainage basins. Such an upland is known as a water divide."
So if the basin is the bowl, the water divide is the rim of the bowl.
Okay, wait, I'm trying to visualize this practically. So if I'm driving across a mountain pass and I reach the absolute highest point, like the summit before the road starts going back down the other side,
Yeah,
is that peak the water divide?
it is. Exactly. When a rainstorm hits that mountain peak, the water literally divides. A raindrop that lands just 1 inch to the west of the peak will roll down the western slope and join an entirely different river system than a raindrop that lands, 1 inch to the east.
Oh, wow. I like to think of it like the pitched roof on a house.
That's a great analogy.
Yeah, like rain falling on the left side of the roof goes to the front yard,
Hmm.
and rain on the right goes to the backyard. The peak of the roof is the water divide.
The terrain itself dictates the destiny of the water.
Mm.
Mountain ranges and high plateaus act as massive traffic cops, permanently separating these giant river basins.
That's wild. Now, the text also includes a fascinating side box here to put this into perspective. It reads, quote, "The world's largest drainage basin is of the Amazon River. Which river has the largest basin in India?"
It's a good trivia question.
It is. And I'll admit, the scale of the Amazon is hard to fathom. But for India, what is the answer to the textbook's question?
The river with the largest basin in India is the Ganga.
The Ganga.
Yeah, it is a staggering expanse of land. Hundreds of thousands of square miles across northern India act as this giant funnel, catching rain and snowmelt and directing all of it toward the Ganga.
So, knowing how basins catch water and how elevated lands divide it, we can really look at how the Indian subcontinent is structurally organized. The text introduces us to two radically different worlds of water.
Two very distinct systems, yeah.
It reads, quote, "The drainage systems of India are mainly controlled by the broad relief features of the subcontinent. Accordingly, the Indian rivers are divided into two major groups, the Himalayan rivers and the peninsular rivers."
And just to clarify, relief features simply refers to the physical shape and elevation of the land, where the mountains rise up and where the valleys sink down.
Right.
India's specific shape creates this stark geographical split.
Let's read how the text describes the first group, the northern giants. It says, quote, "Apart from originating from the two major physiographic regions of India, the Himalayan and the peninsular rivers are different from each other in many ways. Most of the Himalayan rivers are perennial."
Perennial, right.
Quote, "It means that they have water throughout the year. These rivers receive water from rain as well as from melted snow from the lofty mountains."
The crucial word there is definitely perennial. I mean, in botany, you plant a perennial flower because it survives year after year without needing to be replanted, right?
Yeah, exactly.
Well, in geography, a perennial river flows constantly year-round and never runs dry.
And the text explains why they have a dual income of water.
Uh,
They get flooded by monsoon rains during the wet season, but their true lifeline is the ice.
the glaciers.
Right. During the incredibly hot, dry months when the rest of the country is completely parched, these northern rivers are being continuously fed by the slow melting of Himalayan glaciers.
It's basically a massive natural water tower. But the text highlights another physical characteristic of these rivers that is just as important as their water source.
Okay, let's look at the next sentence. It reads, quote, "The two major Himalayan rivers, the Indus and the Brahmaputra, originate from the north of the mountain ranges. They have cut through the mountains, making gorges. The Himalayan rivers have long courses from their source to the sea."
There's a lot there.
Wait, I need to stop right there. They originate north of the Himalayas.
Yes, and this is such a mind-bending concept. I mean, the Himalayas are the tallest mountain range on the planet. But rivers like the Indus and the Brahmaputra actually start in Tibet,
On the far side.
on the far side of these mountains. To get to the ocean, they have to cross the Himalayas.
But how does water cross a wall of rock that is 5 miles high? I mean, it can't go over it,
It doesn't go over, it cuts straight through it.
just through it.
Yeah, that is what the text means when it says they have cut through the mountains, making gorges. A gorge is a deep, impossibly narrow valley with steep, almost vertical rock walls with a river just raging at the bottom.
But hold on, the river didn't just stumble upon a convenient crack in the mountain, right? The text implies the river actively created it. How does liquid water saw through solid granite?
It really comes down to gravity, time, and, well, ammunition.
Ammunition.
Yeah. These rivers start at extreme altitudes. Gravity pulls that icy water down with terrifying speed and force, but water alone doesn't cut rock easily. The river picks up gravel, sand, and boulders along the way.
Oh, I see.
Those rocks get suspended in the fast-moving water, turning the river into basically a high-speed liquid sandpaper. Over millions of years, as the tectonic plates slowly pushed the Himalayas up into the sky, the rivers were busy sawing their way down.
So they were happening at the same time.
Exactly. The mountains rose, but the river cut down at the exact same pace, creating a slice through the rock that we call a gorge.
That is awe-inspiring. I mean, the mountain is pushing up, the water is cutting down, and the water is winning.
Always bet on water.
Seriously. So to understand how this violent process shapes the land far beyond the mountains, the text walks us through the physical journey of a river. Let's read the next section verbatim. Quote, "They perform intensive erosional activity in their upper courses and carry huge loads of silt and sand."
We need to translate erosional activity here. Think of the river's life in 3 stages: youth, middle age, and old age.
Okay, I like that.
The upper course up in the steep mountains is the river's youth. It is fast, highly energetic, and highly destructive. Erosion is simply the act of tearing the landscape apart. The river is ripping rocks and dirt away from the mountainsides.
And the text notes it carries, quote, huge loads of silt and sand. That pulverized rock and dirt becomes the river's luggage, right?
Yes, it's luggage, but it can't carry that luggage forever. Let's hear the next sentence.
Quote, in the middle and the lower courses, these rivers form meanders, oxbow lakes, and many other depositional features in their floodplains. They also have well-developed deltas.
So, as the river leaves the steep mountain gradients and enters the relatively flat plains, this is its middle age, it loses that youthful speed. The water slows down.
Right.
And just like a person carrying a heavy backpack who suddenly stops running, the river can no longer carry all that heavy sand and silt, so it starts dropping it. This is what the text calls depositional features, landforms built by the river depositing its heavy luggage.
And because it's moving so slowly on flat land, the river's behavior changes entirely. It doesn't rush forward in a straight line anymore.
No, it wanders.
Yeah, it snakes wildly from side to side, and those big, looping, snake-like curves are what the text calls meanders.
Which brings us to the Oxbow Lake. This is just a brilliant piece of fluid dynamics. Picture a river meandering so widely across a flat plain that it forms a shape like a giant horseshoe. The water is constantly eroding the outer edge of the curve and depositing sand on the inner edge. Over centuries, the neck of that horseshoe gets narrower and narrower.
Like it's pinching itself off.
Exactly. Eventually, usually during a massive flood, the water decides it's just too much effort to go all the way around the massive loop. It takes the path of least resistance and simply punches a straight line right through the narrow neck.
Just cuts its own corner.
It cuts its own corner. The main river straightens out, completely abandoning that massive horseshoe loop. The ends of the abandoned loop quickly get plugged up with deposited sand and silt, separating it entirely from the flowing river.
Wow.
And you are left with a standalone U-shaped lake sitting quietly next to the newly straightened river. That is an oxbow lake.
It literally leaves a piece of its own history behind. And finally, in its old age, right before it meets the sea, the river slows to a near standstill. It drops the last massive amount of its silt luggage, fanning out into a wide, muddy, triangular network of smaller channels called a delta.
Yep, that's the delta.
So that is the epic life cycle of a Himalayan river. Fast and destructive in the mountains, slow and creative in the plains.
But what happens when you remove the glaciers from the equation? Because the text immediately contrasts those northern giants with the rivers of the south.
Okay, let's unpack this. The text reads, quote, a large number of the peninsular rivers are seasonal, as their flow is dependent on rainfall. During the dry season, even the large rivers have reduced flow of water in their channels.
This is a completely different reality. The peninsular rivers operate in central and southern India, far, far away from the snow-capped peaks. No glaciers mean no guaranteed water during the summer.
So they are entirely at the mercy of the monsoon rains.
Completely. During a harsh, dry season, a riverbed that is a mile wide might be reduced to a tiny, ankle-deep trickle just winding through dry sand.
The text continues, quote, the peninsular rivers have shorter and shallower courses as compared to their Himalayan counterparts. However, some of them originate in the central highlands and flow towards the west. Can you identify two such large rivers? Most of the rivers of peninsular India originate in the Western Ghats and flow towards the Bay of Bengal.
So, because the southern peninsula is an ancient, geologically stable plateau, the mountains are much lower. The rivers just don't have the terrifying gravity-fueled speed of the Himalayan drops.
Right, their journeys to the sea are shorter, and they haven't carved those deep, dramatic gorges.
Exactly. Then we have another major water divide mentioned here. The text says most of these rivers originate in the Western Ghats and flow east to the Bay of Bengal.
Right, if you look at a map, the Western Ghats are this continuous mountain range running right down the western edge of India, parallel to the coast. It acts as a massive wall.
A huge wall.
So when the monsoon clouds blow in from the Arabian Sea, they hit this mountain wall and just dump their rain. Because the peak of the divide is so close to the western coast, almost all that water is forced to flow eastward, draining across the entire width of the country into the Bay of Bengal.
It is the defining topographic feature of southern India. So now that we understand the two main categories, the perennial, snow-fed mountain carvers of the north and the seasonal, rain-fed plateau wanderers of the south, the textbook shifts gears.
Right. It moves from general rules to examining specific, massive river systems. And it starts in the far northwest.
Let's track them.
We begin with the Indus River system. The text provides a brief introduction, noting that rivers like the Indus, Ganga, and Brahmaputra form river systems with their tributaries.
Let's quickly define tributary for everyone.
Yeah. If the main river is the thick trunk of a tree, the tributaries are all the branches. They are smaller streams or rivers that contribute their water into the main trunk.
With that in mind, let's trace the Indus.
The text reads verbatim, quote, "The river Indus rises in Tibet, near Lake Mansarovar. Flowing west, it enters India in the Ladakh. It forms a picturesque gorge in this part. Several tributaries, the Zaskar, the Nubra, the Shyok, and the Hunza, join it in the Kashmir region."
We can track this geographically. We are high up on the Tibetan Plateau, technically in China right now. The Indus is born from glacial melt near Lake Mansarovar. Instead of flowing south toward the ocean, it travels west, slicing its way into northern India through the high-altitude desert of Ladakh.
That's where it carves one of those immense gorges we discussed.
Yes, digging deeply into the rock. And as it moves through this freezing mountainous terrain, it picks up several icy mountain tributaries, the Zaskar, Nubra, Shyok, and Hunza branches.
The journey continues. Quote, "The Indus flows through Baltistan and Gilgit and emerges from the mountains at Attock. The Satluj, the Bees, the Ravi, the Chenab, and the Jhelum join together to enter the Indus near Mithankot in Pakistan. Beyond this, the Indus flows southwards, eventually reaching the Arabian Sea, east of Karachi."
This is where the sheer volume of the system becomes apparent. The Indus leaves the mountains and enters the plains of Pakistan. And there, it gets hit by an astronomical influx of water.
From the tributaries.
Yeah, 5 major rivers, the Satluj, Bees, Ravi, Chenab, and Jhelum, which is actually where the region Punjab, or Land of 5 Rivers, gets its name, all merge their water together into one massive channel, which then crashes into the Indus.
Wow. And then the combined force of all that water travels south to the Arabian Sea.
Exactly.
Let's look at the final statistics the text provides on the Indus. Quote, "The Indus Plain has a very gentle slope. With a total length of 2,900 kilometers, the Indus is one of the longest rivers of the world. A little over a third of the Indus Basin is located in India, Ladakh, Jammu and Kashmir, Himachal Pradesh, and Punjab, and the rest is in Pakistan."
It is a colossal system, 2,900 kilometers long. But there is a vital piece of context here that the textbook highlights in a dedicated side box.
Oh, right, the treaty box. Let's read it, because it moves us from physical geography into the realm of, well, human survival.
Go for it.
It reads verbatim, quote, "According to the regulations of the Indus Water Treaty, 1960, India can use only 20% of the total water carried by the Indus River system. This water is used for irrigation in Punjab, Haryana, and the southern and the western parts of Rajasthan."
This is such an important point.
Okay, wait. I need you to explain this to me. The Indus and its major tributaries flow directly through Indian territory before they reach Pakistan. But we are legally bound by a 1960 treaty to only use 20% of the water passing through our own backyard.
That's right.
Why would a country agree to let 80% of a massive freshwater resource just flow away?
It is a brilliant question, and it strikes at the very heart of why river basins are so geopolitically sensitive. We have to look at the map objectively. The Indus Basin is the absolute, undisputed agricultural lifeline for Pakistan.
Without it, they'd be in trouble.
Without the Indus, much of Pakistan would be an unlivable desert. Because India sits upstream, but technically India holds the geographic power to dam up those rivers, divert the water, and essentially turn off the tap for millions of people downstream.
Which would be an immediate act of war.
Exactly. Water doesn't care about the borders human beings draw on a map, but humans will absolutely fight to the death over water. In 1960, the World Bank stepped in to broker the Indus Water Treaty to prevent a catastrophic conflict.
So how does it actually divide the water?
The agreement essentially divided the 6 rivers of the system. India was granted unrestricted use of the 3 eastern rivers, the Ravi, Bees, and Satluj. Pakistan was granted the waters of the 3 western rivers, the Indus, Jhelum, and Chenab. When you calculate the total volume of all those rivers combined, India's share works out to roughly 20%.
But the text makes it clear that 20% isn't just a political token. It is heavily utilized. It states, quote, "This water is used for irrigation in Punjab, Haryana, and the southern and the western parts of Rajasthan."
It is mathematically crucial. Think about Rajasthan. It is predominantly arid desert. Without the intricate canal systems pulling from that 20% allotment of the Indus system, you couldn't sustain the massive agricultural output of northwestern India.
It really demonstrates how a single geographical feature dictates international diplomacy and domestic food security simultaneously.
The river literally forces us to cooperate.
It's fascinating. But moving east from the international tension of the Indus, we reach the undisputed heartland of India, the basin that sustains the largest population density on the planet, the Ganga River system.
This is a big one.
The text dedicates a massive amount of space to this, breaking it down into multiple paragraphs, so we are going to read it verbatim, step by step.
The Ganga isn't just a river, it's a sprawling, highly complex network of converging waters. We really have to unpack it in stages.
Let's start at the birth of the river. Paragraph 1, quote, "The headwaters of the Ganga, called the Bhagirathi, is fed by the Gangotri Glacier and joined by the Alaknanda at Devaprayag in Uttarakhand. At Haridwar, the Ganga emerges from the mountains onto the plains." And the text has a box here that we should acknowledge. Quote, "The Namami Gange program is an integrated conservation mission approved as a flagship program by the Union government in June 2014 to accomplish the twin objectives of effective abatement of pollution, conservation, and rejuvenation of the national river Ganga."
We will definitely return to the pollution aspect later when the text addresses it directly. But physically, let's look at that first sentence. The headwaters is a term for the original source of a river.
Right.
But notice that the Ganga doesn't just spring out of the ice as the Ganga. It starts as freezing glacial meltwater called the Bhagirathi. It carves its way down the mountains until it crashes into another violently flowing mountain river, the Alaknanda.
Oh, so two rivers meet.
Yes, they meet at a town called Devaprayag. It is only at the exact point of this turbulent merging that the combined force of the two waters officially takes on the name Ganga.
The text then mentions a specific geographic transition. Quote, "At Haridwar, the Ganga emerges from the mountains onto the plains."
Haridwar is a critical checkpoint. This is exactly what we discussed earlier, the moment the river transitions from its fast, destructive youth in the steep Himalayas and spills out onto the incredibly flat expanse of northern India, entering its slower, meandering middle age.
And once it hits those plains, it starts picking up reinforcements. The next paragraph reads, quote, "The Ganga is joined by many tributaries from the Himalayas, a few of them being major rivers, such as the Yamuna, the Ghaghara, the Gandak, and the Kosi."
The Yamuna is huge.
The river Yamuna rises from the Yamunotri Glacier in the Himalayas. It flows parallel to the Ganga, and as a right-bank tributary, meets the Ganga at Allahabad.
The Yamuna is practically a twin to the Ganga, born from a neighboring glacier. It travels right alongside the Ganga for hundreds of miles before finally swinging in and merging its immense volume of water with the Ganga at Allahabad.
But it's the tributaries coming from further east that define the character of the region. Let's read about them.
Go ahead.
Quote, "The Ghaghara, the Gandak, and the Kosi rise in the Nepal Himalaya. They are the rivers which flood parts of the northern plains every year, causing widespread damage to life and property, whereas they enrich the soil for agricultural use."
This is key.
Okay, I'm struck by the duality here. The text explicitly points out a brutal contradiction. Year after year, these rivers cause widespread damage to life and property. Floods wipe out homes, infrastructure, and livelihoods. But in the exact same sentence, the textbook says they enrich the soil for agricultural use.
It is the ultimate double-edged sword of geography. Remember earlier when we talked about the river carrying huge loads of silt, its luggage?
Yeah, the rocks and dirt.
Rivers like the Kosi and Gandak are bringing unimaginable volumes of water rushing down the steep slopes of Nepal. When they slam into the flat plains of India, the water simply has nowhere to go but out. It inevitably overflows its banks, spreading violently across the land.
But when the floodwaters eventually recede and drain away, what gets left behind?
The luggage. Millions of tons of fresh, nutrient-rich, pulverized mountain rock are deposited evenly across the plains.
So the very flood that destroys a farmer's house is the exact same mechanism that makes their land fertile enough to yield crops for another year.
Exactly.
It's a devastatingly brilliant natural cycle. You cannot have the staggering agricultural output of the northern plains without the destructive flooding that delivers the soil.
Nature doesn't care about our houses. It only cares about physics. Now, the text also notes that the Ganga isn't just fed from the snowy north. It receives water from the arid south as well.
Let's read that brief section. Quote, "The main tributaries, which come from the peninsular uplands, are the Chambal, the Betwa, and the Sun. These rise from semi-arid areas, have shorter courses, and do not carry much water in them.
Because these southern tributaries originate on the Central Plateau, which is an area with far less rainfall, their contribution to the Ganga is significantly smaller than the massive glacial torrents coming down from Nepal.
But they still add to the ever-growing volume of the main
So
river.
yes, every drop counts.
Which leads us to the final, incredibly complex act of the Ganga's life. The text reads, quote, "Enlarged with the waters from its right and left bank tributaries, the Ganga flows eastwards till Farakka in West Bengal. This is the northernmost point of the Ganga Delta. The river bifurcates here. The Bhagirathi Hooghly, a distributary, flows southwards through the deltaic plains to the Bay of Bengal."
Okay, we have a brand new, highly specific vocabulary word here, distributary. This is the exact opposite of a tributary.
Let me see if I have this. If a tributary is a branch that adds water to the main river, a distributary is a branch that splits off and steals water away from the main river.
That is exactly right.
Well, why does it happen?
Well, as the Ganga nears the ocean, it is carrying an incomprehensible amount of silt, mud, clay, sand collected from 1,000 miles of journey. The land is so flat that the water is barely moving, so the river starts dropping that mud right into its own channel.
It clogs itself.
Exactly. The river literally chokes on its own debris. The channel gets blocked, so the water is forced to split apart to find new ways around the mud. It bifurcates. The Bhagirathi Hooghly is a major distributary that breaks off from the Ganga and flows south, passing right through Kolkata to reach the sea.
Meanwhile, the main trunk of the river just keeps pushing east. Let's read what happens next. Quote, "The main stream flows southwards into Bangladesh and is joined by the Brahmaputra. Further downstream, it is known as the Meghna. This muddy river, with waters from the Ganga and the Brahmaputra, flows into the Bay of Bengal. The delta formed by these rivers is known as the Sundarban Delta."
This is the grand finale. The Ganga enters Bangladesh, and it collides with another colossal river system, the Brahmaputra. The two giants merge, change their name to the Meghna, and push their combined muddy weight into the ocean.
And the land built by all that deposited mud is the
Yeah.
Sundarban Delta.
Exactly.
The textbook includes two small, fascinating fact boxes about this delta. One says, quote, "The Sundarban Delta derived its name from the samvari tree, which grows well in marshland." The second says, quote, "It is the world's largest and fastest growing delta. It is also the home of Royal Bengal tiger."
The word growing is key there. Deltas aren't static. Every single second of every day, the river is dumping more dirt into the ocean, slowly but surely extending the landmass out into the water.
Building new land.
Yeah, the Sundarbans is a massive, shifting labyrinth of tidal waterways, mudflats, and thick mangrove forests. The roots of the Sundari trees anchor the mud, creating this unique ecosystem that is half land, half water, and perfectly suited for an apex predator like the Bengal tiger to hunt.
There's one final paragraph in the Ganga section, but I really want to spend some time on it because it contains a statistic that completely shifted my understanding of how rivers work.
Oh, I know the one you mean. Let's hear it.
Let's read it. Quote, "The length of the Ganga is over 2,500 kilometers. The plains from Ambala to the Sundarban stretch over nearly 1,800 kilometers, but the fall in its slope is hardly 300 meters. In other words, there was a fall of just 1 meter for every 6 kilometers. Therefore, the river develops large meanders."
This is perhaps the most important sentence in the entire chapter for understanding why the landscape of northern India looks the way it does.
Let me break down the math the text just gave us because it's staggering.
Please do.
If you start at the city of Ambala and follow the river all the way to the ocean, that is a journey of 1,800 kilometers. But over that vast, immense distance, the elevation of the ground only drops 300 meters.
It's nothing.
That means for every 6 kilometers you walk forward, the ground only slopes downward by a single meter.
It is functionally flat. It is as flat as the floor of your house.
So the text concludes, quote, "Therefore the river develops large meanders." Help me connect the math to the meandering behavior.
Water only flows in a straight, deep, fast-moving line when gravity is aggressively pulling it down a steep slope, right? If you pour a bucket of water down a steep driveway, it cuts a straight path. But what happens if you pour a bucket of water onto a perfectly flat garage floor?
It doesn't rush away. It just sort of spreads out, puddles, and wanders lazily in every direction.
Precisely. The Ganga has almost zero forward momentum from gravity because the slope is so microscopic. The river is incredibly lazy. If it encounters even the slightest obstacle, a small mound of harder dirt, a fallen tree, It doesn't have the kinetic energy to push through it.
So it goes around.
It just flows around it. This is why the river snakes and meanders so dramatically.
Yeah.
And because it's moving so slowly, it drops all that silt we talked about, creating the fertile floodplains.
Wow.
The existence of the most densely populated agricultural region in human history is entirely dictated by the fact that the ground only drops 1 meter every 6 kilometers.
That is incredible. The physics of elevation dictates the location of civilization. Now, you mentioned the river that meets the Ganga in Bangladesh, the Brahmaputra. The text dedicates the next major section to this wild, looping system. Let's track its journey.
If the Ganga is the steady, life-giving mother of the plains, the Brahmaputra is the erratic, overwhelming powerhouse of the east.
The text reads verbatim, quote, "The Brahmaputra rises in Tibet east of Mansarovar Lake, very close to the sources of the Indus and the Satluj. It is slightly longer than the Indus, and most of its course lies outside India. It flows eastwards, parallel to the Himalayas."
Parallel to the mountains, yep.
Quote, "On reaching the Namcha Barwa, it takes a U-turn and enters India and Arunachal Pradesh through a gorge. Here it is called the Dihang, and it is joined by the Dibang, the Lohit, and many other tributaries to form the Brahmaputra in Assam." And there's also a box that notes, quote, "Brahmaputra is known as the Sangpo in Tibet and Jamuna in Bangladesh."
The geographical layout of this is hard to wrap your head around at first. Think about the origin point. The Brahmaputra starts high up on the freezing Tibetan plateau, right next to the exact same glacial lakes where the Indus starts.
Okay, I'm picturing it.
But while the Indus flows west, the Brahmaputra flows east. It runs for hundreds of kilometers across Tibet, perfectly parallel to the Himalayan mountain range. It is essentially trapped behind the massive wall of the mountains, unable to flow south toward the ocean.
But then the text says it hits a mountain peak called Namcha Barwa, and the river takes a U-turn. I have to push back here. Rivers don't just do U-turns on a whim. Water goes where gravity tells it to go. How does a massive river do a 180-degree turn through a mountain range?
It's an incredible display of geological violence. The river isn't turning around because it changed its mind. At Namcha Barwa, the Himalayan mountain chain effectively ends in a sharp geological knot. Yeah, and over millions of years, as the land was being violently uplifted by tectonic plates colliding, the river found a weakness in the rock. The water exploited that weakness, cutting fiercely downward, carving a terrifyingly deep gorge, the Dihang Gorge, that slices right through the end of the mountain range.
Letting it escape.
Exactly, allowing the water to plummet southwards into the lower elevations of Arunachal Pradesh and Assam. Gravity found a crack and the river tore it open.
And once it gets through that crack, the personality of the river changes completely. The second paragraph of this section highlights a massive behavioral shift. Let's read it. Quote, "In Tibet, the river carries a smaller volume of water and less silt as it is a cold and a dry area. In India, it passes through a region of high rainfall. Here, the river carries a large volume of water and considerable amount of silt."
This is the rain-shadow effect in action. In Tibet, behind the mountains, the climate is harsh, cold, and dry. There is very little rain to add volume to the river, and the ground is mostly frozen hard, meaning the river can't erode much loose dirt. It's a relatively clean, smaller river. But the moment it crashes through that gorge into India, it hits a wall of tropical monsoon rainfall. Suddenly, millions of gallons of water are added, washing unfathomable amounts of mud and rock down from the steep hillsides into the river.
It goes from a cold, quiet stream to an absolute monster choked with mud. The text describes exactly what happens next. Quote, "The Brahmaputra has a braided channel in its entire length in Assam and forms many riverine islands."
Braided channel.
Quote, "Every year during the rainy season, the river overflows its banks, causing widespread devastation due to floods in Assam and Bangladesh. Unlike other North Indian rivers, the Brahmaputra is marked by huge deposits of silt on its bed, causing the riverbed to rise. The river also shifts its channel frequently."
Let's break that down.
Yeah, because I am struggling to visualize a braided channel. If I look at the Ganga, it's generally one wide, continuous ribbon of water. But the text says the Brahmaputra is braided in its entire length in Assam. What does that actually look like on the ground?
Imagine a massive, multi-lane highway during a rock slide. The Brahmaputra gets hit with such extreme rainfall that it washes down an apocalyptic amount of heavy silt, sand, and mud from the mountains. But as the river hits the flatter valley of Assam, the water slows down just a fraction.
Oh, and we know what happens when it slows down.
Right. Suddenly, the water doesn't have the speed to push all that heavy dirt forward, so it drops the dirt right in the middle of its own path.
It blocks its own highway.
Exactly. It dumps a massive pile of sand, which forms a temporary unstable island right in the middle of the river. The rushing water hits the island, splits into two smaller streams, and flows around it. Then it drops more sand, forms another island, and splits again and again.
It just keeps splitting.
From above, it doesn't look like a single river. It looks like a tangled, frayed rope, hundreds of shallow, shifting channels, weaving erratically around countless temporary sandy islands. That is a braided channel.
And the textbook points out a terrifying consequence of this. It says, quote, "The riverbed rises. If the river keeps dumping dirt on its own floor, the bathtub is essentially filling itself from the bottom up."
Yes. The channel gets shallower and shallower because of the silt buildup. When the next monsoon hits, the water literally cannot fit inside the riverbanks anymore.
So it spills.
It has nowhere to go but over the sides, causing the widespread devastation in Assam and Bangladesh that the text mentions. The river just completely abandons its old, choked-up path and violently cuts a new one across the landscape. The geography is fundamentally unstable.
It is a sobering reminder of why the people living in those regions face such unpredictable challenges every year. Now, leaving the volatile, snow-fed, mountain-smashing Himalayan giants behind, we journey south.
Into the peninsula.
We are entering the world of the peninsular rivers. These are older, steadier, and entirely reliant on the rains. And we start with the geographic rebels, the ones that refuse to follow the rules.
As we established earlier, almost all southern rivers flow east into the Bay of Bengal, following the natural, gentle tilt of the plateau. But two major rivers defy this entirely.
Let's read the introduction and the Narmada Basin paragraph verbatim. Quote, "The main water divide in peninsular India is formed by the Western Ghats, which runs from north to south close to the western coast. Most of the major rivers of the peninsula flow eastwards. The Narmada and the Tapi are the only long rivers, which flow west and make estuaries. The drainage basins of the peninsular rivers are comparatively smaller in size."
Okay, let's hear about the Narmada.
It continues into the specifics. Quote, "The Narmada rises in the Amarkantak Hills in Madhya Pradesh. It flows towards the west in a rift valley formed due to faulting. On its way to the sea, the Narmada creates many picturesque locations. The Marble Rocks, near Jabalpur, where the Narmada flows through a deep gorge, and the Dhuladhar Falls, where the river plunges over steep rocks, are some of the notable ones. All tributaries of the Narmada are very short, and most of these join the mainstream at right angles."
Keep going. Let's do the Tapi right away.
Okay, I'm also going to immediately read the Tapi Basin paragraph right after this, because the text links their behavior inextricably. Quote, "The Tapi rises in the Satpura Ranges, in the Betul district of Madhya Pradesh. It also flows in a rift valley parallel to the Narmada, but it is much shorter in length. The coastal plains between Western Ghats and the Arabian Sea are very narrow, hence the coastal rivers are short."
Right.
Finally, there's a box here mentioning, quote, "The Narmada River Conservation Mission has been undertaken by the government of Madhya Pradesh by a scheme named Namami Devi Narmade."
The single most important phrase in both of those paragraphs, the key to unlocking why these rivers flow backward to the west, is rift valley formed due to faulting.
Let me try an analogy here because faulting sounds highly technical. I like to imagine the Earth's crust in central India like a giant zipper that broke under stress.
It's a zipper, okay.
Imagine two massive tectonic plates slowly pulling away from each other over millions of years. The chunk of land caught between those two separating plates loses its structural support beneath it, and it literally drops down, sinking like a massive elevator, creating a deep, shear-walled geological trench. Is that an accurate way to picture a rift valley?
It is a fantastic analogy. That unzipping and dropping of the crust is exactly what happened. While the vast majority of the southern plateau is gently tilted eastward, gravity dictating that water should flow to the Bay of Bengal, the Narmada and the Tapi rivers are physically trapped at the bottom of these deep, sunken geological trenches.
You can't escape.
And crucially, the floor of these specific rift valleys happens to slope downward toward the west. The rivers have absolutely no choice but to follow the trench. They are funneled westward into the Arabian Sea by the ancient cracking of the Earth's crust.
It's not that the water decided to flow uphill against the plateau. It's that the Earth opened a trapdoor beneath it. That also explains the specific scenic features. The text mentions the river plunging over steep rocks at Dhuladhar Falls. The water is navigating dramatic geological fractures.
Now, once we move past those two west-flowing rebels, the text dedicates the rest of the section to the vast majority of the southern rivers. the ones that behave normally and follow that gentle eastward tilt of the plateau.
The text breaks these down basin by basin, listing their lengths and tributaries. I'll read through these verbatim so we get the complete picture. Pay attention to the states these rivers cross, as it becomes very important.
Go for it.
Quote, the Godavari is the largest peninsular river. It rises from the slopes of the Western Gorges in the Nasik district of Maharashtra. Its length is about 1,500 kilometers. It drains into the Bay of Bengal. Its drainage basin is also the largest among the peninsular rivers. The Godavari is joined by a number of tributaries, such as the Purna, the Warda, the Pranhita, the Mandra, the Wainganga, and the Penganga. Because of its length and the area it covers, it is also known as the Dakshin Ganga.
Next is the Mahanadi.
Right. Quote, the Mahanadi rises in the highlands of Chhattisgarh. It flows through Odisha to reach the Bay of Bengal. The length of the river is about 860 kilometers. Its drainage basin is shared by Maharashtra, Chhattisgarh, Chharhad, and Odisha.
Okay, what's next?
Next, the Krishna. Quote, rising from a spring near Mahabaleshwar, the Krishna flows for about 1,400 kilometers and reaches the Bay of Bengal. The Tungabhadra, the Koyana, the Gaprabha, the Musi, and the Bhima are some of its tributaries. Its drainage basin is shared by Maharashtra, Karnataka, and Andhra Pradesh.
And the final one.
Finally, the Kaveri. Quote, the Kaveri rises in the Brahmagiri range of the Western Ghats, and it reaches the Bay of Bengal in south of Cuddalore in Tamil Nadu. The total length of the river is about 760 kilometers. Its main tributaries are Amravati, Bhavani, Hemavati, and Kabini. Its basin drains parts of Karnataka, Kerala, and Tamil Nadu.
There's a box there too, right?
Yes, and there is a notable box here. Quote, the river Kaveri makes the second biggest waterfall in India, known as Shivasamudram Falls. The hydroelectric power generated from the falls is supplied to Mysuru, Bengaluru, and the Kolar Goldfield.
That's a lot of lists and lengths there, but let's draw out the core insights. The Godavari section gives us a great comparison point. The text notes it is widely called the Dakshin Ganga, the Ganga of the South. Why? Because relatively speaking, it serves the exact same life-sustaining agricultural purpose for the southern peninsula that the actual Ganga serves for the northern plains.
It casts a massive net.
Yeah, it casts a massive net over the land, collecting water from multiple states to sustain millions of farmers.
But there is a jarring fact box dropped right at the end of this peninsular river section that fundamentally changes how we view these southern waterways. The text reads verbatim, quote, 71% of the world's surface is covered with water, but 97% of that is salt water. Of the 3% that is available as fresh water, 3/4 of it is trapped as ice.
That statistic is terrifying when you apply it to the rivers we just read about. Over 2/3 of the planet is covered in water, but almost all of it is toxic to crops and humans because of the salt.
Less than 1%.
Less than 1% of the water on Earth is liquid, available fresh water. And here is the crucial connection. These southern peninsular rivers do not have access to that 3/4 of fresh water trapped as glacier ice. They don't have Himalayan snowmelt. They rely solely on capturing the unpredictable, fleeting monsoon rains.
Which means the water flowing through the Godavari, Krishna, and Kaveri is an incredibly scarce, incredibly precious resource.
Absolutely. Notice how the text continuously listed the states that share these basins. The Kaveri Basin is shared by Karnataka, Kerala, and Tamil Nadu. The Krishna is shared by Maharashtra, Karnataka, and Andhra Pradesh.
Yeah, it mentioned that over and over.
Because this water is so scarce and completely dependent on rainfall, it is fiercely protected by the people who live there. When a monsoon fails, the rivers run low. And when the rivers run low, the sharing of these waters becomes a source of intense, sometimes volatile, legal and political conflict between states. Human survival and the economy of entire regions depend entirely on how that tiny fraction of available liquid fresh water is divided up.
It is a stark reminder that geography isn't just about rocks, it's about resources, which perfectly transitions us to the next section. We've talked extensively about rivers, which are moving water, but still water plays a massive role in our ecosystem and our economy. Let's look at lakes. I'll read the first few paragraphs verbatim.
Still water, okay.
Quote, you may be familiar with the Valley of Kashmir and the famous Dal Lake, the houseboats and shikaras, which attract thousands of tourists every year. Similarly, you may have visited some other tourist spot near a lake and enjoyed boating, swimming, and other water games. Apart from attraction for tourists, lakes are also useful to human beings in many ways. Lakes, a large extent, are called seas, like the Caspian, the Dead, and the Aral Seas.
Right, the inland seas.
Quote, India has many lakes. These differ from each other in size and other characteristics. Most lakes are permanent. Some contain water only during the rainy season, like the lakes and the basins of inland drainage of semi-arid regions. There are some lakes which are the result of the action of glaciers and ice sheets, while others have been formed by wind, river action, and human activities.
Let's look at the specific types.
Let's read through the specific types of lakes the text mentions before we break them down. Quote, a meandering river across a floodplain forms cutoffs that later develops into oxbow lakes. Spits and bars form lagoons in the coastal areas. For example, the Chilika Lake, the Pulakat Lake, and the Kolaru Lake. Lakes in the region of inland drainage are sometimes seasonal. For example, the Samvar Lake in Rajasthan, which is a saltwater lake. Its water is used for producing salt.
That's a lot of categories.
Wait, there's more. Quote, most of the freshwater lakes are in the Himalayan region. They are of glacial origin. In other words, they formed when glaciers dug out a basin, which was later filled with snowmelt. The Wular Lake in Jammu and Kashmir, in contrast, is the result of tectonic activity. It is the largest freshwater lake in India. The Dal Lake, Bhimtal, Nainital, Loktak, and Burapani are some other important freshwater lakes.
And the man-made ones.
Finally, quote, apart from natural lakes, the damming of the rivers for the generation of hydropower has also led to the formation of lakes, such as Guru Gobind Sagar.
Okay, that is a lot of categorizing, but we can simplify the mechanics behind the three main ways lakes form based on that text. First, glacial action. The text says glaciers dug out a basin. A glacier is a river of solid ice, sometimes mile thick, slowly bulldozing its way down a mountain.
Just scraping the earth.
Exactly. It exerts unimaginable pressure, acting like an ice cream scoop, gouging out a giant bowl in the solid bedrock. When the climate eventually warms and the ice retreats or melts, it leaves behind that deep rock bowl which fills with pure snowmelt. That's a glacial lake.
Second is tectonic activity, like the massive Woolor Lake. This operates on the exact same principle as the rift valleys we discussed with the Narmada River.
The unzipping.
Right. The Earth's crust cracks, shifts, or drops due to tectonic stress, creating a deep depression in the landscape that eventually fills with water.
And third is human activity. The text mentions Guru Gobind Sagar. We take a naturally flowing river and we construct a massive concrete dam right across a gorge, blocking the flow entirely. The river has nowhere to go, so the water backs up behind the dam, slowly rising and flooding the entire valley behind it, creating a giant artificial lake, a reservoir used to generate hydropower and store irrigation water.
We also briefly touched on oxbow lakes earlier, the abandoned U-shaped loops of a meandering river left behind on a floodplain. But there is a paragraph at the end of the lake section that poses a really interesting mechanical question.
Let's hear it.
I'll read it. Quote, lakes are of great value to human beings. A lake helps to regulate the flow of a river. During heavy rains, it prevents flooding, and during the dry season, it helps to maintain an even flow of water. Lakes can also be used for developing hydropower. They moderate the climate of the surroundings, maintain the aquatic ecosystem, enhance natural beauty, help develop tourism, and provide recreation.
What's the question?
The phrase that catches me is regulate the flow of a river. It makes it sound like the lake has a thermostat or a control dial. How exactly does a body of still water physically regulate a moving river to prevent floods and droughts?
It acts as nature's shock absorber. Think of a lake that is connected to a river system as an overflow tank. During the intense monsoon season, when a river suddenly swells with millions of excess gallons of water, that surge in water could easily blow out the downstream riverbanks and cause a catastrophic flood.
Right, we talked about that devastation.
But if there is a lake attached to the system, that excess water spills laterally into the wide expanse of the lake. The lake absorbs the massive surge of volume, slowly rising in level, thereby taking the pressure off the narrow river channel. It catches the overflow.
And conversely, during the dry season.
During the dry season, when the river shrinks to a trickle, the massive volume of water stored up in the lake slowly drains back out into the riverbed, maintaining a steady baseline flow of water downstream long after the rains have stopped. The lake acts as a battery, storing water during times of excess and releasing it during times of scarcity.
Which brings us to the final narrative connection of the chapter. We are transitioning from looking at how water shapes the physical land to how it shapes human society and how we, unfortunately, are aggressively reshaping the water in return.
This is the heavy part.
Let's read the final textbook sections. Role of rivers in the economy and river pollution. Quote, rivers have been of fundamental importance throughout the human history. Water from rivers is a basic natural resource, essential for various human activities. Therefore, riverbanks have attracted settlers from ancient times. These settlements have now become big cities. Using rivers for irrigation, navigation, hydropower generation is of special significance, particularly to a country like India, where agriculture is the major source of livelihood of the majority of its population.
Now the pollution part.
Now the pollution section, which paints a pretty grim picture. Quote, the growing domestic, municipal, industrial, and agricultural demand for water from rivers naturally affects the quality of water. As a result, more and more water is being drained out of the rivers, reducing their volume. On the other hand, a heavy load of untreated sewage and industrial effluents are emptied into the rivers. This affects not only the quality of water, but also the self-cleansing capacity of the river.
The self-cleansing capacity.
Quote, for example, given the adequate stream flow, the Ganga water is able to dilute and assimilate pollution loads within 20 kilometers of large cities. But the increasing urbanization and industrialization do not allow it to happen, and the pollution level of many rivers has been rising.
And there's a box about the conservation plans.
Finally, there is a box for the National River Conservation Plan. Quote, the river cleaning program in the country was initiated with the launching of the Ganga Action Plan in 1985. The Ganga Action Plan was expanded to cover other rivers under the National River Conservation Plan in the year 1995. The objective of the NRCP is to improve the water quality of the rivers, which are major water sources in the country, through the implementation of pollution abatement work.
The history laid out here describes a stark, dangerous shift. For millennia, rivers logically attracted human settlements because they provided life, drinking water, crop irrigation, and transport. But as the text notes, those ancient, sustainable settlements have exploded into modern, densely populated industrial megacities.
So let me stop you there because the text uses a very specific phrase that I want to challenge. It says rivers have a self-cleansing capacity. I've heard this term thrown around, and honestly, it sounds a bit like industry propaganda to justify dumping waste. Does the water magically wash itself? How can a river erase raw sewage?
It isn't magic, and it certainly isn't an excuse for dumping, because the capacity has a hard limit. It's a biological and chemical reality based on fluid dynamics. Fast-moving water churning over rocks traps oxygen from the air, a process called aeration.
Okay, aeration.
That dissolved oxygen supports millions of naturally occurring microorganisms and bacteria in the river. When organic waste, like human sewage, enters the river, these bacteria literally eat it. They break the complex organic waste down into harmless, basic byproducts. The sheer volume of moving water then dilutes whatever is left over. That bacterial breakdown and volume dilution is the river's mechanical engine for cleaning itself.
And the text explicitly states the Ganga's engine is so powerful that historically it was able to assimilate and process the raw sewage of a large city within just 20 kilometers downstream. The water would be clean again. But then the text explains exactly how he broke the engine. It's a two-pronged attack.
Right. Look at what urbanization is doing. First, the text says more and more water is being drained out. To feed massive agricultural irrigation canals and sprawling urban demands, we are sucking out the sheer volume of water needed for that dilution process. The river is shrinking.
And the second prong.
Second, the text says we are dumping a heavy load of untreated sewage and industrial effluents. Industrial effluent isn't just organic waste, it's heavy metals and toxic chemicals.
So we are removing the clean water that dilutes the waste while simultaneously suffocating the helpful bacteria under a blanket of chemical toxins they cannot eat.
Yes.
We aren't just making the river dirty, we are completely dismantling the natural machinery that allows it to heal itself.
Exactly. We pushed the physical geography past its breaking point. The river lost its ability to recover, which is precisely why government interventions like the Ganga Action Plan and the NRCP mentioned in the final text box became an existential necessity. We had to step in with artificial pollution abatement because we destroyed the natural abatement system.
It's a heavy reality, but an essential one to understand. Now, to fulfill our promise of reading and utilizing this entire document, we are going to finish up by doing something a little different. We're going to look at the textbook's built-in exercises.
Oh, a pop quiz.
It's a great way to verify that you, the listener, have truly absorbed the mechanics we just spent the last hour unpacking. I'm going to read out selected parts of the exercise section verbatim. Let's see how well we remember the journey.
I am ready. Let's test the knowledge.
Question 1 from the multiple choice section. Quote, in which of the following states is the Wooler Lake located? A, Rajasthan. B, Uttar Pradesh. C, Punjab. D, Jammu and Kashmir.
If you recall our deep dive into how lakes are formed, we contrasted the glacial lakes with Woolar, Wheeler is the massive freshwater lake formed by tectonic activity, the Earth's crust physically cracking and dropping, and it is located high in the northern mountainous region of Jammu and Kashmir.
Right on the money. Question 2. Quote, the river Narmada has its source at A. Satpura, B. Brahmagiri C. Amarkantak D. Slopes of the Western Ghats.
This takes us back to our discussion of the geographic rebels, the west-flowing rivers. Before it falls into its massive, unzipped tectonic rift valley, the Narmada rises in the Amarkantak hills of Madhya Pradesh.
Question 3. Quote, which one of the following lakes is a saltwater lake? A. Samvar B. Dal C. Wular D. Gobind Sagar.
We specifically highlighted the Sambar Lake in Rajasthan when looking at seasonal inland drainage. Because it sits in a semi-arid region with high evaporation and no outlet to the sea, the water dries up under the sun, leaving all the dissolved minerals and salt behind.
Question 4. Quote, which one amongst the following rivers flows through a rift valley? A. Mahanadi B. Tugapatra C. Krishnadi Tapi.
We just touched on this. The vast majority of rivers, like the Mahanadi and Krishna, flow east down the gentle slope of the plateau. The two major rivers trapped in those deep, sunken, westward-sloping geological trenches are the Narmada and the Tapi.
Let's do a few rapid-fire clues from the crossword puzzle section the textbook provides at the very end. Clue number 2 across. Quote, the longest river of India.
That would be the mighty Ganga, stretching over 2,500 kilometers, meandering wildly across the plains because of that incredibly flat 1 meter per 6 kilometer slope.
Clue number 5 across. Quote, the river, which was known as the Sorrow of West Bengal.
The text briefly touches on the concept of flood damage in the eastern plains. Historically, this title belongs to the Damodar River. Before modern dams were built to regulate its flow, its seasonal surges caused catastrophic, unpredictable flooding, perfectly illustrating the destructive power of rain-fed systems we discussed.
And finally, clue 10 down. Quote, the river flowing through fault drains into the Arabian Sea.
Again, reinforcing the most unique geographical anomaly of the peninsula, flowing through a tectonic fault into the Arabian Sea in the west. This is the Narmada or the Tapi.
And with that, we have completed our mission. We have taken you on a massive, highly detailed journey through the drainage basins of India. We started by defining the very shape of the land, the basins acting as massive bowls, and the mountain divides dictating the flow of every raindrop.
We covered a lot of ground.
We tracked the perennial snow-fed Himalayan giants that saw through solid mountain rock and choke on their own silt in wild, braided channels. We contrasted them with the seasonal, rain-dependent peninsular rivers navigating ancient tectonic rift valleys.
We talked about lakes, too.
We explored how lakes act as nature's shock absorbers, storing floods and relieving droughts. And finally, we confronted the harsh reality of how our exploding urbanization is systematically dismantling the self-cleansing machinery of our most vital resource.
It is a remarkable testament to the terrifying and life-giving power of moving water. But I want to leave you, the listener, with a final thought to ponder based on the source text we just analyzed. The text explicitly noted two things. First, rivers like the Brahmaputra frequently shift their channels entirely due to immense, unstoppable deposits of silt. The Earth is constantly rewriting its own pathways. Second, human industrialization is actively draining the volume and destroying the biological resilience of these rivers.
I see where you're going with this.
If we consider both the relentless, violent geological shifting of these waters, combined with our own unprecedented interference in their natural flow, what happens to our geography maps in 100 years? Will the massive river channels we have built our megacities around even be in the same place? Will they have shifted, dried up, or flooded outward? Or will the very lifelines of the subcontinent be entirely unrecognizable to our grandchildren?
That is a chilling and fascinating question to sit with. Those static, comforting blue lines on the map really are an illusion. They are alive, they are moving, and they are changing the world with every passing second. Thank you for joining us on this custom-tailored deep dive. You are now armed with the true geographer's understanding of India's rivers. We'll see you next time.